microanatomy of a tag, and this is the tags that we're going to deal with in this class. These are specifically HTML and XML tags that can really have a lot more than simply just those things I showed you before. They can have internal delimiters. So here's the tag, right? Would you agree? That's the first delimiter and the second delimiter of the tag. And there's more structure in here. There's more stuff going on in there than simply just the name of the tag. Doesn't have to be in all markup languages, but in this case there is. There's internal delimiters. Here's an internal delimiter right here. This little quote delimits a value. Here's a little delimiter right here, a space. Right? You may have thought in the past of spaces as being kind of, you know, they're just there for convenience, but in this case, you don't have a space there, then this is a different tag. This is the IMG SRC tag if there's no space. But with a space, excuse me, it becomes the IMG tag with an SRC, what would you call this thing in HTML? Attribute. It becomes the IMG tag with an SRC attribute. Or as we'll see later, the IMG element with an SRC attribute. Okay, and now the tags also have internal structure. They're nested. There's tags within tags. And so what if I had a tag called lie, and then inside the tag that's called lie, I had another tag that was called lie. Now what would I have said about that sentence? It's true, right? The lie is a lie. And in this case, I said the TR is a part of the table. And the TD is a part of the TR that's part of the table. So this context is additive. I got the context of table here, I got the context of TR here, and I got the context of TD. They all sum together to tell me how to interpret this line right here. Okay, so what I'm hoping that I'm doing here is if you already know HTML, I'm getting you to think about HTML in a much more abstract way than you ever have before to prepare you for being able to create this kind of stuff. So here's another thing about the markup that we're going to work with. What's the difference between this that I'm showing here and this that's behind for the computer? Nothing, right? And that's because every bit of white space, there's all sorts of space between here and here. All that white space is for your eyes only. And when the computer interprets it, it squashes all that white space down to a single space. Right? And so as far as the computer is concerned, this is much more efficient. Why? It takes a lot less storage. Right? I don't have to store all that white space. That all takes up bytes to store spaces and tabs and character terms, etc. However, as far as you're concerned, which one is better? This one or this one?
The gray one.
Obviously, clearly, right? And how many of you guys have been frustrated when you go view source on a web page and it looks like this? Right? And it's almost impossible to parse. But if it lays it out like this, it's really easy to parse. Why is that? Because of the structure? Tell me more.
It helps you read every line easily, so you don't have to internally make a structure in your mind. You just see the structure in it.
Okay. You're using a different part of your brain, aren't you, on this one than this one? In this one, I have to intellectually say, okay, table begins here, table ends there. So therefore, everything is in the table. As you're saying, I'm building piece by piece a mental map of this thing. I look at this, and the visual map is the mental map. There's a direct mapping between what I see and what I want in my brain about what's going on here. And so it's really easy for us to see this and interpret it and understand what's going on, whereas in this one, it's impossible. But what does the computer do? Does the computer make an internal visual representation of the thing and then use that to figure out what its structure is? No. The computer says, well, here's the beginning of the table. Here's the end of the table. Okay. Here's the beginning of TR. Here's the end of TR. It does that, so it really doesn't need that representation. So there's a basic dichotomy between what the computer needs in order to understand or interpret this markup and what you need. You need that white space. And so you'll see nicely and happily inside the land of XML, there's always a way to make this into this with one button click, which we would love to have in HTML. And I'll leave it to you as a little exercise to think about, well, how come we can't have that little button in HTML if it's so useful to us? Right? And some applications try to do that. Firefox, I think, is pretty good at trying to make the view source a little bit easier, but there's reasons why even Firefox can't do it. Okay, so some constraints. Shorthand tag word. Tag names stand for real words. What does this shorthand stand for?
Table.
Pretty straightforward, right? Wouldn't it be nice if they were all that straightforward?
Yes.
What does TR stand for?
Table row.
Table row, right? You can kind of guess. All right. What does TD stand for? And those of you who already know because you've looked it up, don't say. Right? You don't know. If you don't know, you're not going to know by looking at it. TD. Table. Or what do you wish it would say? Because what is it? Column. Cell. Something like that, right? If it said cell here, if this said table, row, cell, would it be absolutely immediately apparent to you what it was? Right? Or table, row, column? But instead it's table, TR, TD, table data. Right? We also have LI and LD. You know what an LD is? You know what an LI is? LI is a list item, right? Inside a list. LD is list data. Whatever the heck that means. I don't think I've ever used it in my life, but it's there. So the tag names stand for real words, or they should. And in old school computerese, the fewer letters you used for something, the better. And why was that? Like if you look at programmers and people who, especially people who consider themselves hardcore programmers, you know what their variables look like? A, B, C, D, E, 1, 2, 3, 4. Right? No matter what they stand for. It doesn't matter what they're trying to store, what they're trying to hold. They name them with 1 character, 2 characters, the fewer characters, the better. Why is that? Or why was that?
You didn't used to have as much space. You know, the computer that took up a whole room is opposed to, you know, what we can put on our thumb drive now.
Exactly. Exactly. The first program I wrote was stored on a cassette tape. Imagine that. Actually, it wasn't the first program. The first program I wrote was stored on cards, index cards, right? But the first storable program I wrote was stored on a cassette tape. How much room is there on a cassette tape for computer programs? Not a heck of a lot, right? So every byte counts. And so when every byte counts, you want to be as terse as possible. Unfortunately, a lot of people have carried that into the age now where we don't store things on cassette tapes anymore. Right? We have enough storage that we could actually spell the word row, especially since it only takes 1 more letter. Right? So the upshot for you guys is when you write your markup, when you create your tags, you don't have to worry about space constraints. You don't really have to say, well, it's, you know, a 5-letter word is worse than a 4-letter word or a 3-letter word. I want you to be as elaborate as you need to be to make your markup clear. And that way other people can use it, which for our purposes is more important than saving a byte or 2 here or there. Okay, so when they invented HTML, however, they were still back in that era, and so a lot of their tags, you can see they were sort of half and half. You know, a lot of HTML tags are actually reasonably well-formed English words, and a lot of them are completely obscure. So it's almost like there was 2 guys doing it, right? There was one who was kind, and then there was the one who was the hardcore programmer who had to have everything in 1 and 2 letters.
Well, you know, XML makes so much more sense, especially as you talk about it more and more. And so why isn't the internet in XML protocol?
Good question, and we're going to get to that in just a couple of slides. And I'm tarrying, and I better not tarry quite so much. Okay, tarry over this. And I'm just going to go. Okay, so here's an important point.
Me too.
Huh?
I'm
You're
laughing
funny.
at your attributes are children too.
Yes, attributes are children. And really there's only one thing going on. And this is hard to wrap your head around, especially if you've been doing HTML for a while. There's only one thing going on. There's parents and children. And for some reason that to this day I've never gotten a good explanation for, the people who invented HTML way back when decided, well, let's have 2 different types of children. Let's have the kind of child that goes inside the tag, like this, can't really see it very well anymore, like inside of here, col span. Let's have that kind of child, and let's have a different kind of child when it's actually a tag nested inside the tag. They're both the same thing. Logically, whether I'm an attribute or a child element, I'm the same thing. I'm a child of a parent. So there's parents and children. And that's really all that's going on. And whether the child is represented by an attribute or represented by another element inside the element, it's the same thing. And we're going to come back to that again when we see XML.